participation. So I tried to send the email again, second time, just before the start of the seminar. We have today two visitors to Equisat. One is from Germany, other one is from India. So Germany visitor from Germany is a close friend of mine. We work together at CIET Cali, Colombia, on a network project on trying to identify the resistant genotypes both in sorghum and palm millet for acid soil tolerance. So my friend name is, I have to read his full name because I know him as Felipe. I will try to read your full name. This Spanish name is very difficult. Dr. Andres Felipe Rangel Becerra. Okay. Perfect. Perfect. Thank you. He is a senior scientist at YARA GmbH Co, Germany. It's a Norwegian company. So he had the first graduation in 1997 in agronomy. They call it agronomy engineer at National University, Columbia. 1994 and 2001, we worked together at CIET on an important project which was funded by ICA, sorghum and palm millet. 2001, 2007, he went to, I think, Germany. Yeah, and did his MSc and PhD on aluminum resistance in common beans. In 2008, again he came back to CIET and did his postdoc on again aluminum tolerance beans. Since 2009, he is working with YARA German company in Germany, research center. Hanninghof. I don't attend on P efficiency project. Okay, Philippe, the floor is yours.
First, thanks. I feel like at home after 14 years being here as an internship. I got that opportunity in the sorghum project. It was really interesting because I was able to jump from soil science to plant breeding, and that paved the way to go to plant nutrition. And now I escaped from the CGR system and went into the private sector, trying to get an answer of how we can go through research to the farmers direct and which impact we are doing with our research. It's really good to see now that the CGR system is also changing in that direction and is approaching more to deliver a market value issue for the farmer. So trying to complete this win-to-win aspect. I'm just going to give this talk in two aspects. One is what is the meaning of YARA and why is YARA meaning of crop nutrition company? Because most of you will just see a private company selling fertilizer, the one who is going to the retailer, the farmers go to the retailer, buy the fertilizer, and job done. So actually, this is not what we are through YARA. So YARA is a pioneer company. It's founded in 1905 in Norway and was the world's first production for nitrogen fertilizer, mainly using calcium nitrate. With this, YARA created a big impact not only for the farmers, but also among the global concern of how to improve the use efficiency for the farmers and doing this through mineral fertilizers. So talking about numbers, just to go quite fast with numbers, the revenues are quite high. So these are numbers that are in English. I'm a Spanish speaker, it will be quite difficult to say. But it doesn't mean this number is nothing until we see how many employees we have in the world and how many countries we are touching. And this is more important if we are seeing YARA as a partner, as a global partner or for production of nitrogen fertilizers, ammonia and nitrate, where we are the global one player. Also quality NPKs, where our research show how important it is to be into a balanced fertilization. Also the introduction of specialty fertilizers for sectors like fertigation and advanced farming practices. And most important of all of this, the marketing and the distribution. So our colleagues like Dr. Vinaya that are facing the face of the farmers who are transfer the knowledge that in some areas we are developing as a basic. No, it's not going down. It's not. Um, yeah. As a global partner, we are in 150 countries where we have YARA plants. These are in these brown colors. We have also joint ventures. That means that we also get collaboration with specific partners to develop the products in our own house or to dismiss this highly costly fertilizer production. Also, sale offices around the world and these development programs. Something that is really interesting from here are the research units. So YARA is among the few companies in the world who is able to invest in research, trying to get the best deal of these fertilizers. So with this unique global view, and we are trying to deliver a crop nutrition program. So we are not trying to deliver a fertilizer. So we are trying to get the farmer in the whole way. So for this, we have a worldwide marketing organization and this global distribution network. We try to give these fertilizer products, but mainly agronomic solutions. So what are the agronomic solutions that are attached to a product? How you can get the farmer the best input or the best aspect for what he is investing, especially when he is not able to invest in your farm. So due to this is almost 30 to 40% of the inversion in the farm. Also, we tackle the local market knowledge, so we get the knowledge in-house. We try to see this from the face of our agronomists in inland, and with this we develop different strategies regarding agronomic and application competence, and we try to also create product differentiation, so how we can create products that resolve problems on the field. So that means that higher probability, profitability through the value chain means a win-to-win aspect. So YARA, we go to the distributors. From the distributors, we also contact the growers. We are in charge to develop this knowledge or use the knowledge that is already available and trying to get this knowledge to the grower so that the grower profit can increase. And with this increment, we can also get our profit. So it doesn't matter if we get the profit ourselves without getting the profit for the farmer. So that will be not really true. And that is a new form of making business true for the farmer. So the YARA crop nutrition focus in knowledge, or deep knowledge about the crops. So with this, we develop what is already in knowledge literature. We get the advanced publications. We try to develop our own knowledge. We use different tools and services. So this is the type of application competence. And with this application competence, we also develop these portfolio combinations. So trying to get the product that is specific for the farmer at the right time in the specific moment when the plant and the farmer is needed. So this is basically made in 3 centers. So research center in Hanninghof, where I am based, is a plant nutrition and application research center. We are a team of 15 scientists and also PhD students that work with us. So one of our commitments is to keep the new generation of students going into into this plant nutrition approach. We have also competence in plant nutrition, plant physiology, environment, soil science, sensor technologies, programming and modeling, all of this based to a plant nutrition concept. It's a multi-culti ambient, so there are different nationalities also to face with different problems around the world, and also different types of research projects. I will go later on. We have our own field and greenhouse facilities and also lab analytical aspects in units. So the focus areas are based on global agricultural challenges. So like the challenges that are facing here, for example, for ECRISAT and for many of the CER system, how to manage better resources, how to create sustainability, how to cope with water stress and drought stress-prone areas, and also how to use resources best. So from this, the concern of environment and sustainability is really important. And basically, the projects that we are conducting and this greenhouse gases emission, the carbon footprint of not only from the production side of the fertilizer, but also going to the farm gate and what this means for the farm gate. This leaf cycle assessment and also the bioenergy. So just to give an example, what means this approach of carbon input? So YARA technology improve the fertilizer management and reduce this greenhouse gas emissions by about 50%. If we take the average of the world, we have here the CO2 emissions from nitrate fertilizers. So in the BAT technology, so that means that in the production technology, we achieve with the YARA catalyst a reduction between 35 and 40% of the emissions of CO2. And with technologies and through improvement of recommendations, we are also able to go below 30 or another 10 to 30% using, for example, technology like YARA and sensor. The transport, granulation, some of these things will remain constant from some of the fabrics or some of the people who is producing fertilizer. One of the most important aspects is the reduction here in the nitric acid production due to this catalyst and also this. So that means that YARA is leading toward controlling the greenhouse emissions from the fertilizers and is giving a carbon footprint warranty. And this is one of the key aspects of our company, how to deal with the environment and how to keep this under control. Regarding crop competence, crop nutrition knowledge, crop-based fertilizer management, local knowledge adaptation. So it's trying to get the best of what was in the ancient of managing the culture. What is the farmer practice? How we can improve this and how we can get into this win-to-win relationship. The product portfolio means that we are trying to develop products and create differentiation from the normal products, and with this, trying to get the right product for the right moment in the farming place. We have other two centers, so that's with Postgrum in Norway, Sluiskil in Holland, in Pocklington in UK, where quality control and product development are the main aspect. So this is, we can say, this is the upgrade part, and we are in the downwards of this channel. Application competence. So here YARA is also a leading company. Since almost 14 years, we are working with this crop sensing based on the N sensor and N tester to give fertilizer recommendations and to avoid problems, for example, like leaching of nitrates, when to apply the fertilizer to avoid problems with water table, and also how to get better into this fertigation aspect. How this sensor looks is on the top of the tractor. He's able to sense the greenness of the of the crop, with this greenness of the crop and the calibration of how the plants are growing, is able to give the specific recommendations. So you are able to differentiate the applications according to the greenness of the crop, and with this you will apply fertilizers accordingly. So you will not waste your product, and you will get the best results, controlling also the ambient aspect. Regarding knowledge transfer, there are analytical services. I was really happy to see today the lab and get really good input from there. We also develop this training and local trials. Actually, my colleague is in charge to give this training here in India. And all of this is basically going into how to support crop and production and how to deliver the best practice. Here I come to the end of what is the global challenge that we are working nowadays in YARA. And basically, it's nutrient use efficiency. My project related to phosphorus fertilizer use efficiency, water use efficiency, and nutrition. So, which elements can cope better with the efficiency, how to use better the water. Around the world, and with this, I want to just that you get the idea that there are also in the private sector, there are companies who are also committed with these global challenges, and I also seen for this as a partner to make research. It's open now. Yes. So related, my project, improving peer recovery efficiency of mineral fertilizers. Phosphorus is an essential plant nutrient. So when you think about phosphorus, the first thing that you need to search is the storage of energy. So that is the main aspect of phosphorus. And it's not only in plants, but it's in all living organisms. And this is mainly to the conservation and the transmission of the genetic information in the plant. So it's the survival of the plant. It's a main component of sugar, phosphate, nucleic acid. So it's involved in all relationship with ATP. Its function cannot be replaced for any other element. And what means for the eyes of the farmer is a reduction of the growth. So this is a typical symptom in maize. There is a stunted growth, and this is just because the cell division is stopped, and the root growth will start to grow, trying to search for more P, but there is in some form the energy will get exhausted and the plant will not grow anymore. Good things of phosphorus, it promotes flowering, tuberization, it can control the quality, for example, in potato, the starch synthesis. At all is a mean of energy for the plant. How you get this into the soil? So the current concept of forms of P in the soil, you can get values between 100 until 100 milligrams P per kilogram as a total P, and it's separated in 4 compartments. These are conceptual compartments. Actually, the plants will take phosphorus for the soil solution, and then it will get replaced by the readily available, and in some form, there are forms that are occluded or are stored in the soil. The mineral fertilizer will be applied to enhance the plant growth and to enhance the nutrient solution concentration. But something that you cannot avoid is that these are also moving into less available forms. Why is going into less available forms? So water-soluble phosphates or phosphorus fertilizer don't remain soluble in soil solution. So this different type of phosphorus fertilizer will react in alkaline soils as a precipitation with calcium. At the end, you will get some kind of the calcium phosphate at the end appetites. In acid soils, absorption and precipitation are leading the aspect, so you will have iron and aluminum oxide, hydroxide, getting the whole complexation of phosphorus. How the farmers, or how is the recommendation to cope with this small amount of P in soil solution for the plants? So one of the aspects is you can get to build up your soil. So that means you raise the P content to an adequate level. This is one-time application, which is extremely costly because you will apply between 100 and 420 kilograms P2O5 per hectare. That is amazingly how much fertilizer you need to transport, how much fertilizer you need to apply. And nowadays, with this situation of the price of fertilizer, this will be probably not the economic way. Other aspect can be that you can gradually increase, you can apply amount of fertilizer about the crop removal and trying to get into 5 or 6 crop season into an area where your soil can cope with the phosphorus deficiency. And once the soil is in a stable level, you can go into this maintenance approach where you apply the rates depending on how the crop is removing. How good are these recommendations, or how good is this system can be also challenged. And so, for example, P recommendations in Brazilian area for soybean, you will have that for 3 tons of production, that is normally the top of the production in some areas, you would need to apply only 60 kilograms P2O5 per hectare. But in reality, what you are applying here is fertilizer rates up to 250, and depending on the fixation capacity of the soil, you will get into 120 up to 480, depending mainly of the clay content and the content of aluminum and iron oxides, with a percentage of recovery in research aspect 24, but mostly in a farm gate 5 to 10%. There are forms to enhance this efficiency. This is a band application. You reduce the rates of phosphorus that is applied for the plant, and you are giving phosphorus for the plant and less phosphorus to be reacted with the soil due to the band of application. So this indicates that it's possible to meet the crop requirement, that means the demand, and this is possible for the crop season. So I got the literature that is available in different sources or internet, CAP files, and all these aspects. And I try to select some key factors where you can get into the P availability in soils and how to get this plant acquisition. So phosphorus availability in soils means soil properties that affect the P supply to the plants. And here there are chemical aspects and the positional aspect. Chemical is the amount and the nature of P in the soil matrix. This is basically where you store your phosphorus when you apply the phosphorus, and from which store the plant is taking this phosphorus. And the other, how much volume you need to apply. So you see that the broadcast, you need to apply too much. You apply 100% of the soil that is touched by the roots, or you get into a band application. So probably you are just getting into 5–10% of the soil volume enriched with phosphorus, promoting to use other sources. Or how to get into distribution and mobility. Are all sources of P moving equally in soils? Are all of them equally stored in different containers? And really important, all this phosphorus availability in soil cannot be working alone if you not work with the acquisition by the plants. So that means how you improve the exploration area, especially during the early establishment of the crops. So that is where you see the deficiency. So I'm going to present some part of the results that we have in the project regarding the amount and nature of P in the soil matrix. If we get again to this conceptual about P forms in soil, we know that this part represents soil in solution, surface absorbed, and in that direction is going into more strongly bond. And this means also that you can extract in the lab easily, or you need to use a stronger acid or stronger alkaline sources. And this, in the conceptual, is also related to the accessibility of the plant. So how the plant access every of these containers. So fractionated experiments can cope with this for the long, also for the short term. You can also get what is the impact of management. You can also get the impact of fertilization. And all of this is just by increasing the extraction power in the alkaline area or in the acid area. And with this, you can relate this to the accessibility to the plant. So how each fraction is accessing this. Something really interesting, it was believed that these are not available, but actually this is directly influenced by the rhizosphere of P-efficient plants. So these sources can be taken up by some specific crops, and that is one of the important aspects of rotational crops and intercropping. So this is an example of a German soil in the long-term field after 21 years application. Here we have the control, just the application of nitrogen, application without phosphorus. Then you increase half of the removal of winter barley, 1 times the removal of winter barley, or 2 times the removal. And what you see after 22 years is that there is an increase in the total P content of the soil. You are also increasing the water-soluble content. And if you make this fractionated and you see, where is the storage? What you can see is that here again, in this direction, you are getting the increments of fertilizers, and you will have also the different fractions, including also the organic fractions. And what you see is that this part are available for the plant and is influenced by the application. So you increase the availability for the plant. But what is really striking is that you are also increasing this phosphorus attached to aluminum, iron, even in neutral soils and in temperate areas. You are also contributing to calcium phosphate here and also to the residual. If you see the same picture for a tropical soil, this is a tropical soil in Colombia. It's an oxysoil with very low P content. The native savanna, you will see that there is a really small amount of readily available or what is accessible for the plant, and you get an increase in what is residual. Or if you think about this concept, you will see that is mainly driven by the organic sources that are recycling all the time in the native savanna. So if you get the effect of changing the use to pasture and applying 2 times TSP, you will see that you get immediately an increment in the availability in the soil, but you also get a tremendous increase in the residual one. So what is attached to iron, what is attached to calcium, and what will be attached to the organic matter or the resilience or into a mineral. And if you get this into a monocrop where is applied 5 times, then you will see a tremendous increase with the rate of phosphorus application into this aluminum and iron oxide. So this fraction is a sink of your fertilizer. How available is this for the crop? That is something that needs to be developed with the rotational crops and how to get this the main use of this research. Something good from phosphorus in this type of soils, or actually in most type of soil, is that it will not get lost from the system. So leaching is not an issue. Erosion is a really a strong commitment, so that is where you can probably lose most of your phosphorus. So what means potentially retained and is rapidly transformed? So how rapid is rapidly transformed? If we get the same soil and we apply 40 kilogram triple superphosphate and we analyze after 10 days, what we see there's a tremendous increment in the availability of phosphorus, but there is also extremely attachment of phosphorus to aluminum and iron oxides. So that means that it's quite rapid. But is this the same for all the sources? So here what we did was to test how calcium phosphate, ammonium phosphate, polyphosphate, and rock phosphate are delivering phosphorus to different containers. So these containers, again, in the same schema, what we see is that almost all the water-soluble sources give the same amount of phosphorus to the readily accessible after 2 weeks. There are different, they are delivering different amounts of phosphorus to the low accessibility, so that means to the aluminum and iron phosphate. And this is something really interesting, because then that gives you an idea how you can deal with your fertilizer. Something really interesting, this very low accessibility is actually the calcium phosphate area, and is where the rock phosphate are delivering phosphorus. And this phosphorus is in some form in acid soils protected to react with the aluminum and iron sources. So with this, the plant, and by the action of the plants of the root system, you can get this into the efficiency of the crop. All fertilizers will contribute to something that will be non-accessible or the residual. So that means that these rapid transformations means that is driven by the form of fertilizer that you are applying. So not all the forms give the same effect to these compartments. And in any case, this concentration in soil solution will be taken up by the plant. So how this will cope with the mobility, so to replenish what the plant is taking. And for this is still the idea that large amount of fertilizer need to be applied to get this concentration-driven diffusion to the roots. So that means that we get into distribution and mobility. And this distribution and mobility, we were just testing with a simple setup. We apply fertilizers on top in the middle of the columns. And then we applied water without avoiding movement through the borders, so just the movement of P through the columns. And after 2 weeks, we cut 5mm segments and to see where our P was recovered. So with this, we have two different types of soils. For example, here is a Brazilian soil. Both come from the Cerrado area. So there are oxy soils with very low pH. And clay soils will tend to fix more phosphorus than sandy soil. And we test this with different P forms. And what we can see is that there is a kind of penetration until 4 or 5 centimeters. So this is the potential movement for a band of fertilizer that is applied in these soils. And the other interesting aspect is that they are also able to penetrate even up to 5 centimeters. And this is depending of the source of fertilizer that you are applying. So rock phosphate will remain in the position of application, so close to the point where it is applied, and that is why it needs to be broadcast and incorporated in the whole 20 centimeters of the soil. While calcium phosphate will remain on the top, ammonium phosphate will try to penetrate, polyphosphate are penetrating through the soil, so that is enhancing the mobility. If a farmer asks, look, I am applying 100 units of water-soluble fertilizer, where is my fertilizer? If someone is saying that this is just going into a locked area in my soil. So this answer, you can give it here. So after 2 weeks, on all the fertilizer, you still have in between 6 and 10% of the fertilizer in a heavily fixed in pea soil, still as water-soluble, while here is between 9 and 16. So after 2 weeks, part of the fertilizer, this is still water soluble, so it's still readily available for the plant, and it's still contributing to the plant. Movement and distribution is quite similar to the total. So that means that you will have an impact of solubility of different forms of phosphorus, like orthophosphates. You will have also the polyphosphates, how it's moving also due to solubility. So polyphosphate are thermal fusion of orthophosphate. In the process of production, you remove the water with high temperatures. And this is something that was patented in the YARA unique process due to this extraction of water in the melting process. The polyphosphate were concentrated. So how this contributes? So this is explained here. So compound NPKs are produced to different routes. So you have the rock phosphate, you have the ammonium salt, potash salt, and you can treat this with nitric acid. This will deliver a product that is basically MIP with polyphosphate. So if you treat this like normal process, that is this sulfuric acid, or the wet process, you will have a DAP-based NPK compound. And some factories also use a mix of different acids, so you will have a different ratio between DAP, MIP in the same component, the same granule. So all of this means that not all the fertilizers are recommended for one area. So you need to check which is the composition of your fertilizer to go to a specific problem or to go to a specific soil or a specific crop. So we try to get in engineering how our products can be better, and what we saw is that not all the products can act equally. So what happens if we use a mix of products, like for example something that we was discussing today, what happens if you use rock phosphate with small amounts of DAP? So if you get water soluble in a small amount to get the rock phosphate used, what happens if you get the rock phosphate treated with organic sulfuric acid and you try to increase the water solubility? So all these solutions, what it made is that combination of rock of different form of phosphorus is probably a good hint to give the farmer a solution. And with this, what we tried to engineering was a YaraMila product where we have balanced nitrogen sources, available phosphorus. We check the consistency of the quality and how is the superior handling for the product. I'm just going to concentrate now in the available phosphorus, just to give you an idea what means this route of production and how the fertilizers are given. You have here the orthophosphate in green, so normally this MIP, DAP, or triple superphosphate. You have granular and preeling process. In the preeling process, you will get immediately this polyphosphate aspect, or you will get a normal granular produced by the wet, or by sulfuric acid, compared to rock phosphate. So what you see is that you have a kind of mixture of water solubility, polyphosphates, the calcium phosphates that will deliver phosphorus in different times. So how this relate again to our concept? This is again in the Brazilian soil. We already saw this. They're really accessible for stray sources, and this is the composition of this YaraMila product compared to another granular. And what we see is that balanced nutrition tries to cope what the stray sources are giving. So you have almost 60% of your fertilizer after 2 weeks getting freely available phosphorus for the plant. So this means that you can penetrate also into the soil if you compare the mean value of the orthophosphate against this YaraMila again. What you see is that there is the same penetration capacity. You get also immediately available concentration, or again, this 60%. So you can cope with the root growth in the early stages, which is a really clear and a really probably the message that you need to get. The earliness of the crops, or the establishment, this vigor is really important to get the efficiency of the crop. If you get how they contribute to the low accessibility, so that means the aluminum and iron phosphate complex. So what we see is that there are changes in depending of the sources that you are using, and you also see there's a change depending on which fertilizer you are using, which NPK component. And here these NPK are between the calcium phosphate and the ammonium phosphate, because this is basically an ammonium phosphate NPK. Part of this NPK is attached to the polyphosphate. So the polyphosphates are used in analytical research in the lab to get how much aluminum and iron are attached to the organic matter and how much phosphorus can be there. That means by removing aluminum and iron, you can get how much is the potential of this fraction to retain phosphorus. So if you get here, this is the orthophosphate in solution, and you will see that with the time, it will get reduced like it's normally in soils. The polyphosphate can be really high at the beginning, and once the hydrolysis is taking place, you will see that they maintain a constant supply of phosphorus. This area of 0.2 ppm is an area that is saying that is the amount of P in nutrient solution to keep between 90 and 95% of the yield potential of almost all crops. So that means that you have a component that is moving deeper. You are also giving a second shaft of fertilizer once the hydrolysis take place. And you can also increase the availability of other micronutrients like zinc, copper, and manganese. If you get into the low accessibility part, you get also here differences regarding also this getting into the composition of a rock phosphate, but actually is a type of decalcium phosphate. It's not a crystal apatite like the one that is delivering by the rock phosphate. It will contribute like all of them to this residual part. But if you get how this decalcium phosphate will deliver phosphorus for the plant, then you will see that it constantly releases P to the solution during the time, even at pH 6. So that means that you will support the plant during the crop season with different protected sources. Regarding balanced nitrogen source, what we have here is the total recovery for nitrogen applied in different forms to the same Brazilian soil as urea, ammonium sulfate, and ammonium nitrate. And what you can see here is that there is no nitrification in these soils. So that means that the combination of sources can be also a solution to create a synergy with the phosphorus. Why? Because this combination will determine how heavy or how healthy is your root growth. And root growth is something really important for phosphorus because it's known to be an immobile source. So the more that you have a surface area tracking for phosphorus, the more efficient that will be. And that is something that is really important, for example, for sorghum, who have a really strong root system, also with an efficiency system or like organic acid exudations. So what you see is that ammonium, pure ammonium feeding plants will get a reduction in the root growth. Combination of sources can give healthy root growth. And this healthy root growth, if you see it in the aspect of root growth and morphology, you have the nitrate plants growing with many lateral roots here compared to the small branching roots that are not able to explore the soil. Something that is also interesting is how this impact of different N forms are related to rhizosphere. In alkaline soils, it's known that DIP acidify the system, making phosphorus more available because it's going into the neutral area and is releasing phosphorus to the solution. In acid soils, probably is the opposite. If you are able to apply here as nitrate compared to ammonium, and this are the same plots here, where these plants represent the same, and we was tracking what happened with the acidification in different pockets. And what you see is that there are acidification, but not really striking, not really high. That will be something like 3.5 here, where you will enhance the solubility of aluminum and you will track more phosphorus, so you will keep less phosphorus available for the plant. And you will keep also less root system growing to get the phosphorus that is in the soil. So with this, what we can see is that by keeping a balanced source of nitrogen, you can get a good synergy with the phosphorus that you are applying. So at the end, what you will see is that the key messages, you can mix different sources to boost the root growth, to deliver phosphorus later on during the crop season, and you are also delivering phosphorus that is not getting fixed into this acid soil. and it will be biologically available due to the root system that is touching this. Some examples in Argentina, so comparing MIP with NPK applications, what you see that there is a stronger root system, there is an early vigor for the plant of maize, and this represents that with just with a half of the amount of P that is applied, you can get more yield, and you can enhance the efficiency of the you can enhance the P use efficiency quite high. You can also get this into this startup concept in Spain. So the normal practice, the traditional practice is that you apply this in October, then you have the plant the whole winter there, and during the tillering, what you see is that this is the P uptake. So actually in this area where you have more tillers, more roots, is the active uptake of the plant. The traditional way is that you apply only nitrogen here. So what happens if you get this when the roots are starting to grow? And with this aspect of synchronizing what the plant is requiring in just-in-time concept, what we were able to do was to get increasing the yield almost to 20% of these 6 field trials in northern Spain. But what is really interesting, we were able to reduce the amount of phosphorus that was applied to the soil. Something that is really interesting from this concept of mixing different sources, if you compare the change on the soil P content in the different fractions using triple superphosphate, the control plant, and YaraMila, what you see is that the control plant tends to reduce and consume whatever that is in the soil. Rye is among the most efficient plants to remove P from the soil. So what you will see is that it is able to remove the residual part. And in the triple superphosphate, you see there is still a high contribution to this iron aluminum forms of P. And with the YaraMilas, what was really interesting to see is that you are promoting the use of previously stored fertilizer. So this is something that is really important, because then you can make use of what you applied before, and you can make use of your investment in the farm. So again, to these key factors, so the chemical aspect, so it's really important to see the amount and the nature of the P that you are applying, how different forms of P will contribute to this aspect, how is the volume, and what is more important, how you will increase the exploration area. So that is the message, the combination of forms, so how to use this water-soluble to promote plant growth and keep using what is in the soil. And thank you for your attention.
No, we are going to answer some questions.
Yeah, yes,
so the seminar is open for questions or comments.
Nice presentation. Like in most of the countries in West Africa, we come across a lot of phosphorus deficiency. Right? In fact, it's one of our breeding objectives there to breed for P deficiency. And do you have any information on your products being tested and their performance?
Yes. So breeding for P efficiency, and so immediately you need the low P soils to get into there, because then what you want to use is the phosphorus that is stored in this conceptual model into the aluminum iron forms or into the calcium forms. So one of the important aspects there is you can use plants that are more efficient, root systems that are able to explore this to exude organic acids or to exude protons in the case of alkaline soils. to get more into the impact of mycorrhizas. But in some form, these sources will be, with the future, more getting down. So that means that not only the breeding purpose of getting plants into these low pH soils, but also how these plants will respond when you have the management is really important. So with this, what we have is hints that some of the traits that you are getting into these deep rooting systems or this plasticity of the root system can be also coped with better use of small doses of fertilizers, a pocket of fertilizers that you apply to the seed of the plant. So this interaction between creating varieties that are efficient to explore the soil, but also are efficient to get what the farmer is able to put is really important. And that is why the combination of both systems need to be there. If you don't combine this in 3 or 4 seasons, you will not get any response.
Any other question?
Other question, I'm entomologist, very difficult for entomologists to understand this much chemistry. But in a general thing, in developing world, particularly in Asia, the fertilizer cost is going up like anything. The last 2 years is doubled. So what the farmers are trying to do is apply less and get more. Is there any way that we apply a foliar spray and get rid of this almost 100 pre-application to the soil? For any, these crops like 6 months crops like groundnut and maybe, like crop like rice.
Yes.
One more thing is now in India, we are trying to, the mode of application. In Maharashtra, they produce the biscuit formulations of fertilizer and saying that 25% to 50% chemical can be, fertilizer can be saved. So that is the point where we are now worried. One is foliar application to save quantity of P or whatever fertilizer.
We have not heard P being supplied through foliar.
Yeah, no. You can say because this is India, so I should answer. Actually, if you see, this foliar application of tea is started since 2003 and 4. Even if in Maharashtra, particularly for grapes and as well as pomegranates. The foliar grades are particularly this monoammonium phosphates. That is a foliar fertilizer is there. This is 12610 as well as monopotassium phosphate 05234. By actually, particularly for fruit crops which are unable to take the nutrients through the roots, and if it is a waterlogged condition and a critical period is there, so then there is no option for you to apply the fertilizer to the soil. So, on that circumstances, if you are spraying this 100% water-soluble fertilizers, which are residue-free and free from heavy metals, so then they are getting excellent results, and that are also environmental friendly, and that was also endorsed by the CPA board. And similarly, the second thing is that cakes, whatever I'm mentioning, that is not at all a good source. Because what they are doing, they are mixing some of the cakes, means maybe some groundnut cakes or some other cakes with the DAP and SSP, and they are making that. But day by day, if you will store that product, immediately if you apply, you will get some benefit. But if you store, that value is reduced. Maybe Dr. Cerrado can also endorse this.
We have our expert keeping quiet, but
Yeah.
non-experts are asking questions.
I think I think there was a concept of really indigenously preparing mud bombs.
Yeah.
That means you have clay soil. You put small amount of urea or whatever fertilizers, and you really place them in the rice paddies at one point. And by diffusion of those ammonium or urea, whatever you are applying, it occurs very slowly. That means the ammonium can last longer in the soil and perhaps can cover a larger time of growth. Yeah, I think the problem is if you prepare them immediately and you can apply, I think the labor charges are so high. Then the other thing, if by chance you are not able to apply immediately, when the soil, clay soil dries up, lot of that will be fixed, and it will be very difficult. I think labor charges are becoming really a handicap in all these labor-intensive technologies.
For only one nutrient that is more suitable, that is for bentonite sulfur, and sulfur is now coming, so that is coated with clay, bentonite clay, so which has a swelling and shrinking properties. To that they are injecting this elemental sulfur, that is 90% sulfur is there. So when it is applied to the soil, because of swelling nature, it absorbs weight 1:20 ratio, it is absorbs the water and it is swell up. Then it will be disintegrated. From that the sulfur will come, then it reacts with the thiobacillus in the soil, then that forms sulfates and it will be available. For only for that element, sulfur element, it is successful, but not for other nutrients. It is much more successful for that taking method.
Okay, I have a question, Felipe. Whether the fertilizers contribute to the atmospheric gases? If so, your YaraMila is more efficient, or in terms of reduced contribution to the gases in the atmosphere, like nitrogen fertilizers?
Yes. So you saw the contribution of ammonia fertilizers to the gas emission compared to the nitrate-based fertilizers. Also, the ammonia will contribute to volatilization, which is not the case of this balanced nutrition of ammonia and nitrate. And by keeping this balance, and by keeping the pH system in the root zone balance, you will avoid these volatilization problems.
But you presented the data mostly in relation to plant growth and all that.
Yes, but also in the plant factory. So one of the important aspects of YARA, one of the key aspects is in the factory process is where you can get between 30 and 50% of the reduction already for the emissions. So you get already to the farm gate with a product that is already 50% below the average product. So with this technology, what we are trying to get is to give from the farm gate a product that is environmental friendly, and then with our crop nutrition approach to give the best effect. So for example, by this work in Spain, by applying fertilizer when the plants are needing, so when the roots are actively taking. So in this tillering process during the early spring, you get the plants producing massive tons of roots. So they are just producing roots. Or for example, in maize, just by changing from the 20 days after planting to the 30 days, you will get from 4 meters to 110 meters just in 10 days. So if you apply the right fertilizer in this moment, you avoid problems like volatilization, leaching. So you avoid this contribution to the gases, and that is something why we are also investing too much in this research about gas emission. So actually, the PhD student that is mentioned in our group is a PhD student that is working since 3 years in how to cope with these greenhouse emissions and A2O emissions from fertilizer.
Mainly, sir, nitrogen, not phosphorus.
Not
much.
Not much, yeah?
Yeah, the phosphorus, I mean, there will be the DAP or the MIP that are introduced, so that is attached to this.
As a secondary source, it may.
Yeah.
My question is whether your
YaraMila
is going to have less effect on the volatilization.
Yes, it will
compared
have
to others.
yes, sir. Actually, it will have less impact on this volatilization process. Because it consists both nitrate, because this is a nitrophosphate range of fertilizers. It contains both nitrate as well as ammonia. Because ammonia is more contributes towards volatilization rather than nitrates. Nitrate, in case of nitrates, it's almost zero.
So what you will see is that you will avoid this concentration of ammonium here, so you will avoid the volatilization process for one side. And from the other side, what you will get here is that you will get not into this acid pH will promote volatilization. You will get into a neutral area that is reducing this volatilization. So that is why this synergy between the two elements is really important.
Okay, so Felipe tells me that he is willing to write the joint projects with the research scientists on P recovery. So those who are interested, please join with him writing the proposal and getting money, both for his research as well as the research. Okay. With this, let us appreciate Felipe and his colleague